and make sure it's recording. Okay, so yesterday I mentioned that the platform can be used to build any type of service, whether it be physical automation, whether it be infrastructure service, whether it be an NFV service, or whether it's a combination of all of the above, right? So it can be used for all of them. And the claim that we made yesterday is that if you use this framework, this platform, then you can go 90% faster. So that's the claim, and I put out some reasons why we can really quickly turn around services because of the auto generation of the API, the FastMap, which automatically infers the update and the delete and the redeploy sequences, so we don't have to write scripts for that, the transactional guarantees and things like that, right? So today we will basically go and validate most of that, right? It's one thing to make claims, but let's start to validate. And what I'll do for today's agenda is I'll go over use cases, the VPN use case. So we'll have a quick look at a layer 2 VPN and then the layer 3 VPN use case. And then we will look into the cross-domain orchestration where we have, let me go full screen, where we have APIC controller and ASR 9K routers. So NSO is providing a service which spans across multiple domains, the data center domain and the MPLS domain. Okay. And then we will also look at an NFV service. So this is like a hybrid service. It involves programming the physical environment, the virtual environment. So we will go over the YANG for the service. We might even look into some of the mapping. Remember, we mentioned yesterday the steps involved to build these services, and I'll go over them again today, the steps that are involved, so it becomes crystal clear. And when you do your lab, when the labs that I have set up, then everything would fall in place, right? So don't worry if there's some gaps. All those gaps are going to be filled when we all do the labs, right? So that's the idea. And I don't have this demo with me today, but I can set it up for tomorrow maybe, where we take the NFV demo use case that I was talking about. So we take this use case, the NFV use case, and we break it up into two domains. So we have two NSOs for two domains, one for MPLS, one for data center, and we consume the same outcome, but this time the master of master NSO would instruct the two NSOs underneath to get the outcomes in those respective domains. So it's sort of like the master of master is composing the higher order outcome, the higher order service, by leveraging the services defined by the domain, the orchestrators for the different domains. So this is a very common pattern that we're seeing for a lot of service providers like Telstra and Level 3 in US. And this architecture definitely would be required at some stage at Reliance, right? So this is really, in an organization which is really big, it's really hard to put one orchestration platform like NSO across the entire network layer. Every domain has got their own infrastructure, and you cannot have one single NSO spanning across that. It's just the administration, the administrational boundaries will not permit that. So as a result, we have multiple NSOs, one for each domain, or even many per domain, if that is what is required. And each of these NSOs can be installed and updated independently, and the net packages, the network element driver, the net packages can be updated independently of each other, and the service packages can be put on the different ones, can be put on these different domains under the control of the administrators for that domain. So it's a very realistic architecture that takes into account the organizational realities of the big service providers, and at the same time, it offers the same benefits of NetConf YANG and the whole data model-driven approach towards orchestration. So you don't lose any of that even when you go to this sort of hierarchical orchestration approach. So I'll try to run this demo tomorrow maybe, because I don't have it set up in my environment at the moment. And that's pretty much it for today. So we'll go over those use cases and we'll take a deep dive. And the main point is for you all to ask questions as we go through them, if anything is is not clear for any of these use cases. So let's jump into these use cases. Before we jump into it, I thought it might be a good idea just to give you a quick glimpse of Yang. And I was told yesterday that some of you already know Yang, right? And some of you already have some understanding of Yang and NetConf, which is good. But I guess the main idea with Yang or any other modeling language, whether it be C or Java, if you want to use that to design your data structures, at the end of the day, this is just a language, right? So the more someone is good at modeling and abstraction, the better use they can make of this language. So there is nothing incredible about the language. It will look really simple when you look at it. Actually, that's one of the key points. It's simple, and it's very declarative. It's like a text file, and you can just go and define this Yang. But the power really comes with a person who has that experience where they can creatively model services in the right way. And sometimes you have to iterate multiple times. You do the first cut, and then you get some reviews from the colleagues. Based on your past experience, you might make some adjustments, and you might iterate. And this is the whole DevOps sort of agile methodology where we build things, we improve things in an iterative fashion. So let's start with a little bit of Yang introduction. And for people who are already familiar, I'm going to go over this very quickly. So a leaf, you'll see in the models that I'm going to present to you, a leaf is something that can hold a value, So a leaf can be something like a IP address, or it could be like a name of an interface, or a description of an interface, or an MTU. And every leaf has to have a type. Remember I mentioned that Yang is really precise. Everything there's a strict type that has to be associated with every piece of data. Just like we went and modeled the entire configuration space of the different platforms in the network layer. Similarly, we use the same Yang to model our services. So when we define our services, we use a lot of different leaves, and in these, these leaves have to be typed. So you have to say the type of the leaf. Usually it'll be like a string, or it would be something like a integer. Similar to what we see in a programming language, right? Nothing different here with the leaf. Now, one of the other things that we get in Yang is these constructs to create hierarchy, to organize data in a nice way, in an intuitive way. Now, if you think about SQL data, sorry, was there a question? I'm just going to mute everyone. If you've got a question, just unmute yourself. So with the Yang, it allows us to also structure the data in an intuitive way. Now, if you think about an SQL table, the way we can structure data in SQL table is very flat, right? So we have a table and we have columns, and that's it. So we can't really have hierarchical representation of data. And sometimes when we do network configuration or service configuration, we actually need a hierarchical way of describing that data. For example, we might have a list. I'm getting a bit of echo. Let me mute everyone. If you have a question, then you can unmute yourself. Okay, so where was I? Now, if you take an example of a list of interfaces, inside an interface, we might have, for example, a container to contain a lot of other elements. So we don't, we can, when we design our services, we can keep them flat. We can go, this is our variable 1, variable 2, variable 3, variable 4, variable 100, variable 200, but you can see how difficult it gets in terms of readability, and it's not intuitive enough anymore. So that's why we have in Yang constructs like container and list to basically organize the data in a hierarchical way. And you can think of list as like a folder. So you can have, like folders inside folders. So like you can go to as many levels as you want. And container is like something which can have just one element, right? So that's a container. Very simple constructs. Then there is this other one called leafref, and leafref is a little bit interesting. For people who have done C, you can think of leafref as like a pointer. For people who have done Java, in Java, you never have the, when you declare a class and you have objects, you always have a reference to that object, right? So it's always a reference. So leafref is like a reference. And basically what it allows you to do is from one part of the tree, it allows you to refer to another part of the tree. So if you're designing a service and you need to get an input, for example, you need to get an input, a PE router, then you can have a leafref in your service, which can basically be, be pointing to all the list of devices available or the list of PE devices. And that basically means that the user can only select from the devices that are being pointed to. And I'll go into more details, and it'll become a little bit more clear. But sometimes when we want to attach a service policy to an interface, we want to make sure that the policy map actually exists. So in those cases, underneath the interface, we might do a leafref to the list of all the policies that are available. So you can only pick one from the available ones. So you can't just put a garbage name in there. So that's what the leafref allows you to do. Leafref allows you to, from your service, for example, point to another portion of the tree and allow you to select something from the other portion of the tree as opposed to just put some random value in, right? So that's what a leafref, it's really powerful. And sometimes it can avoid an operator shooting themselves in the foot. So if they pick, for example, they pick a PE router and then they want to define a site that is attached to that PE router, then we can do a leafref and say, hey, only let the operator select the interfaces on that device. So they can't just put a garbage interface string in there. They would have to select an interface that actually exists on that device. So you can do a leafref to the list of interfaces on the device that has been selected in your service model. So that's the power of leafref. It can give you that
Bilal, question here.
References. Sure.
Yeah. Yesterday, when we were describing service models as data structures, right, we weren't really covering or trying to incorporate inventory information as explicit as interfaces, right? So where would that come in from? I mean, is it to be defined explicitly in the model, or can we really make it part of a resource pool, or maybe get inventory on the fly for specific device, target device type?
Sure. So so the first thing that we do in NSO is when a device we bring a device under management, we tell NSO, here's the device, here's the IP address, and here's the port. And NSO does a sync from. As part of that sync from, it would parse the running config, for example, of that device. And then you have not the inventory, but you have all the information about the different interfaces that are available on that device. So as soon as you bring a new device under NSO, whether it is by discovery or whether it's by whether you manually enter it or whether you call an API on NSO to add a device, straight away you get the model for that device. You get the data for that device as a model, and as a result, what is available to you already is all the interfaces on all of those devices. So you know it just by NSO doing a sync from. So that's part of the information that's available to you already when you do a sync from. Now,
does it also include things like loopback interfaces that one must have defined as part of the config?
Correct. So all the loopback would also be available. So anything that is captured in the running config would automatically be available in NSO when we bring the device under management. So it sort of like gives you some information. Now, inventory can mean different things to different people, and there's companies that sell million-dollar products out of inventory. But it really depends on when we are about to provision a service, what all information do we need?
So say we want to really shortlist it down to some rather calling it inventory, right? I would say a list of configurable resources on the device.
Yep. So what we have in NSO is, you're right. We can have we have a package called Resource Manager, which we can use at setup time. So there is the runtime. So there's the design time where we design our services, right? Then there is a setup time where we set up all the different pools that might be required when the services are being activated. And then there's the runtime when the order comes in and we instantly activate the order. So at setup time, based on our design, obviously, we will set up pools. We will set up pools for whatever things we need. It could be for VLANs, it could be for IP subnets, it could be for route distinguishers, or whatever it might be. We can also set up pools, and we have some customers who are doing that, is something called, they call it like a credit manager. So you can have something like a credit manager, which is, again, a pool. And when you allocate services, you take from your credit manager, and it gives you some credit, and then you can use that you can use this, for example, to model bandwidth on an interface. For example, you don't want to put more than 50 tenants on the one port channel or whatever it might be. So you can model that as a pool with credit in it, and then as your tenants come in, you grab some credits out of it, and eventually the pool is going to run out. And when you decommission the tenant, automatically we give it back. So all this is done at the design time. Then at setup time, we set these pools up, and then at runtime, we just automatically the service would allocate from these pools, and at decommissioning, it'll give it back to the pool. So this is for the information that can be auto-generated or can be auto-inferred in NSO. But there might be certain other information that is required which we cannot model in this way. And you're right, we will have to supply that from a northbound system. That's one way, as part of a parameter. Or we can push that information, build a model in NSO, and I'll show you an example today. We can build a model called a mini topology, where from a northbound system, we can push data into that, and we can keep that updated, the mini topology, which has whatever information that we need at service provisioning time. So we can keep that up and running, updated whenever we have new information. So that's sort of like a data model that is on the side, ready to be looked up when the time comes. Then when the service order comes in, we go and look up and get the latest data from that model, and we use that. So we have an example where we have like a mini topology where we put all the devices that we have in our VPN, in our MPLS, the PE routers, and we also have all the links between them, and we push that into NSO inside a model. Where does that data come from? It could come from multiple sources. It could come from different sources. So that's another way of doing it. One is you push it down as part of the service parameters, number one. Number two is you create a separate model, and you keep that model up to date by calling APIs from somewhere and making sure that auxiliary data is up to date, so that when service provisioning happens, we use that auxiliary data, right? That's another second option. And the third option is to set up these pools and make allocations from the pool and return it back to the pool. So it really depends on how we design the service, but these are some of the obvious choices that we had, right? Okay. So let's keep moving.
Bilal,
Again,
a little silly question, right? Say there is very minimal
sure.
configuration, maybe just IP WAN DHCP on the device, right? And the device is reachable for us by that means. Then what happens? What about the interfaces there? I mean, everything is in a admin shut or admin down kind of state, right? So then how does how do we go and provision those from an NSO perspective? Or how do we,
Yeah.
from a leaf rest perspective, right? How would we do the mapping? Because everything is right now admin down except maybe the one WAN port which is reachable.
Yeah. So NSO can go into that. One of the things for NSO to manage a device is NSO has to have connectivity to that device, right? So it could go over the WAN, or it could go over an out-of-band management, or it could create a tunnel by using, like we have, like for IWAN and all, Flex VPN, where we can have like a management hub and go over the WAN and right. So we connect to the device.
So my
other,
question
right?
was that because in the running config there would be only minimal configuration at that time, right? Or there is in fact only IP WAN DHCP as part of the config. How would it determine the upper state of what all? Because let's not call it as inventory, but all the configurable resources, right, on the device, which are all the interfaces. How would it determine their admin and upper state, and then maintain that in its, say, own configuration database or some data store, right?
Yeah. So at the moment, NSO, the way it is right now, it would basically get your running config, and as part of your running config, you will have shutdown, no shut, so you would know which interfaces are up, which interfaces are down, and that information is we do a sync from, and you get it in NSO. So all that information is available in NSO as a model. So I guess what I'm trying to say is by default, the thing that is available is it can read and parse your running config and present to you as a model. Now, once it has parsed your running config, then we know all the different interfaces. Even if it's down, underneath the interface, there is a leaf called shutdown, right? So we will see if there's a shutdown or no shut, so we can find that out. So that's the configuration state. So that's what you get with NSO when it does the sync from, right? So that's what.
Or rather the device model, while describing the device or the set of device models, should have built this entire information into the tree, so that NSO when it traverses the tree, sees that the admin state is down, but the resource is still available. Should I need to bring it up in provision?
Correct. So you can think of NSO as sucking in the running config, right, and parsing it. It parses it, and it qualifies it against the Yang model. It does a one-for-one mapping from the running config, and it goes through the models and converts them into Yang, and then it makes it available as Yang. So, whatever we can infer from that Yang, from the running config, that's available in NSO, straight out of the box. Right. But if there's some information, state information that is not...
Bilal, so this is Krishna. So Girish, just to explain, so if there is no shutdown, an interface is in a down situation, then there is a problem. If it is a shutdown, then because that's a part of a running config, we will be able to find it out. But if the interface is in down state and we have a full configuration, then upper state will not come to the NSO. So wherever, either in CCM, we need to maintain the inventory, which interface we have already used, which interface we have not used. That inventory will be there with the NSO if we have configured through the NSO from today onwards. But before 1st January, whatever we have done before NSO coming into the picture, that we need to keep somewhere, and we need to maintain the inventory. And we need to tell to NSO that 1/1 is free, so push this configuration on 1/1, right?
Yeah. So that is where the abstraction would come in, that when the request goes to NSO, somebody is pre-qualifying or doing a pre-check whether this inventory really is got it.
That's why we are actually, because of we have now from NSO perspective, we already, you can say, it's not a green field, right? So there are already configuration there. So we need to actually get that inventory, keep it in CCM, which IP we use, which port we use, and what is empty, and that we need to pass it to the...
the other approach could be to sync from the device, right? Based upon how successfully or how well the device is modeled.
Sync from device is still give you
admin state, not upper state.
Which interface is not used.
Yeah, it will give me admin state and not upper state. Yeah.
Correct. So that is the difference, right? So that's why we need to do that. Sync from anyway we need to do. There is no option for that, right? But still we need to maintain inventory somewhere, and there is a logic for that. We are saying this should go on that port, this should go on that. If it is microwave, then it should go there, for example, right? Or if HDFC as a customer should go on 1/1, and then HSBC then should go on 5/1. If that is our logic, then that logic has to be maintained somewhere. Either we maintain as a tenant ID in a NSO, or you maintain in a CCM and give from there, right?
That's right. I think you guys understand. Yep, that's pretty much it. And you're right, Krishnaji. Whatever I'm talking about is the configuration state, right? NSO doesn't at the moment. It hasn't been a big thing, the operational state so far, and people have used through NSO show commands and things. I mean, there is a way to model the operational state in Yang. But at the moment, all the use cases have been more config-centric, and I think.
But then it is as good as modeling the MIB, right? I mean, rather than say just creating a set of show commands for different sets of opposite information.
If you already have the MIB, then you give it to NSO, and NSO automatically generates the NED from it. Right? If you already have the well-formed MIB, it has to be a well-formed MIB. You give it to NSO, and then NSO would give you a Yang model based on that MIB where you can get the oper state.
Understood.
Automatically. So you don't have to handcraft that, right?
Yeah.
If there is a MIB. Yeah. Okay. So let's have I mean, some of these design decisions we probably have to do it another time, but it's good questions. So these are the Yang. And most of the times, these are the constructs that we use. There's a couple of other ones that you will get to see, something like enumeration, which is very common. If you've done any programming language, you're familiar with enumeration. You're just listing all the different kinds of values something can take from the start, so that you can't give any garbage value in. So that's enumeration. And then there is another one called choice, where you can have a choice between multiple types. And we'll go into that when needed, but most of the time you're using a leaf or a list or a container or a leaf ref. Those are the ones that we use majority of the times, and they're pretty straightforward, as I mentioned, right? And the main point of this slide here that you're seeing is that you can nest them as many times as you want, right? So you can keep nesting them. And the reason why you would nest them is because you're trying to model something and it makes sense to do so, is because it's more intuitive. So if you're designing a model for a car, so your main container is going to be a car, right, called car. It's going to be a container. And then inside that, you will have a list of, for example, wheels. And you will put some constraints, and you'll say the minimum number of elements for that list is 4, and the maximum is 4, because you can't have a car with 2 or 3 wheels or 1, right? So you do that. And then you have another list of doors, which could be, you can put a constraint there and say it could be minimum whatever. So, this, and then in the door, you can have other components inside. In the door, you can have like a window and a lock and buttons. So you can have the containers, and the hierarchy is basically to make the model intuitive, right? If the operator is looking at it, they should be able to, maybe understand some portion of what the model is trying to describe.
Stupid question, right? We don't have any macro like hash define in here, right?
No, we do. See, that's the thing with software. When we start applying the principles of software, reusability is a big thing. Right. So in Yang, there is a big thing in terms of reusability. It's not really a hash define. We call something called grouping. So we define a bunch of things. We call it a group. And then if you want to keep using the same one again and again and again, we just go use group multiple times, and then we basically reusing that. If you want to define some scalar values, like some numbers, magic numbers and stuff, you can do that. And I'll show you some example there, enumerations that you can use, and each of the value of the enumeration can have a value, like a string value or some value, so you can do that as well. So the ones that I'm talking about here are the basic ones, really basic ones. There are more, things like enumeration, as I've mentioned, and choice, and a few other ones if you read the Yang RFC. But these are the ones that will get you up and running really quickly. And the main point of the slide is you can nest them as you like, but just go easy. It's not that just because you can nest, you'll nest, is because you'd want to nest when it makes sense to do so, right? When you do your code reviews between your team, and I'm sure you will come up with something that makes sense to the team. So that's usually how we do the service design and service review, by just getting a review done. Okay. And then go to the next slide. And we've spoken about this examples, and I'll just walk through this over here. So on the left, the service is called Layer 2 VPN. It's a list because we can have as many elements as we want. Each one is going to represent a tenant, right? For example, Holden or Volvo or Maruti, so that's a list. This line over here, augment under services. So this is an interesting concept. The slash represents the root of the tree. So there is one tree stored in CDB, and it's like a folder structure. Just like we have a Unix folder structure, the Yang tree is like a folder structure. But the good thing about the Yang tree is that you can declare a portion of the tree, and then you can attach it to whichever branch you want. So it's sort of like, it still ends up being in the one folder, one under the root, but you can define whatever you want, and you can attach it to whichever part of the tree that you want, right? And here we are declaring Layer 2 VPN, and we're attaching it under root. There is a folder called services, for example, so we're attaching Layer 2 VPN to the services node. But if you look at on the right side, this service here, the main service is inside a container, VPN, and then there's a list of layers. Here we are not attaching it to the services node, right? So why would you do one or the other? Really, it's up to you. Wherever you can put your service wherever you want in the tree. You can put it straight under the root, or you can put it. You can have a node called services, and then you can put your services under that node. It's really up to you. And the other thing, as I mentioned, in the future, you can define a model, and then you can come and augment it anywhere in the tree. So in the future, you can define another model in another package, and then you can come and add your model, for example, underneath the services. So you can basically, it's like the iOS parser, where you can come and add stuff anywhere in the tree. Sort of like a similar concept where we can add like a container or a hierarchy, a sub-hierarchy. We can add that to anywhere in the tree, right? So it's just letting you know so that you don't get confused when you see some of the Yang models for the use cases. And as you can see over here, when you define a list, you have to define a key. So key basically uniquely identifies the element. Just like you have a table and then you have rows, then every row has to have a unique key, so that later on we can go back and refer to it, right? So if you want to go and make a change to Maruti or Volvo or Holden, we need to know the key so that we know which one we need to change, right? So that's really the key. Every time you have a list, you have to have a key. So, I mean, in here, this is a snapshot. When I expand it out, you'll see all the other ones, but you can see every list has to have a key, and the key has to be unique, right? So that's by definition, the key has to be unique. It's just by definition. As soon as you try to add another element in that list, you can't give it with the same key. It's with the same key values. It has to be unique for it to be a different element, right? And then you can see the same sort of construct, list, leaf. So you can see a leaf, which is a name. You can see a leaf interface number. You can see a leaf remote IP. You can see a leaf pseudo ID, and you can see nest. How the hierarchical nature here. So the big container outside is a list container. List as in like it can have multiple elements, but it's still like a container because it's containing everything inside it. And underneath that you have a leaf called name, and then you have another list, a list inside a list, endpoints, which is to represent the sites for a given VPN. So for Volvo or for Maruti, you might have many sites. That's why you need a list. And then for every site, you need to have a PE device. You need to have an attachment point where the CE traffic is coming in. You need to have a remote IP for the other site, for example, the the other side of the pseudo wire. And then you need to have a pseudo wire ID. So one of the things you might say is, why do I need to supply the pseudo wire ID? Because as you remember, once you define your service model, the API, the CLI, the web UI is automatically generated. So that means every time you want to create a layer 2 VPN for Volvo or Ford or Maruti, you'll have to supply a pseudo wire ID. So one of the things we can do is, this is just for illustration purposes, we can use the resource manager and create a pool. Because pseudo wire ID is, some numbers have a very localized significance, right? We don't really need to expose it to the northbound system. There's no value in exposing that. So it makes sense to get it from a pool, right? Why would we want to explicitly have to specify that? And if I go on the right, similar sort of
Bilal,
arrangement.
Yep. Say key name is visible to the northbound system, but then can the pseudo wire ID be just randomly generated? I mean, do we need some sort of a random number generator, or NSO would keep track of how many such integers have already been allocated for services through its services database or something like that?
Correct. So in NSO, what we do is we, at setup time, remember how I was talking design time, setup time, runtime. So at setup time, even before the first order has come in, we go and set a pool, right? A pool of IDs, and we say this pool is going to be used for the allocation of pseudo wire ID. And we also say this pool ranges from 1 to 2 million or whatever, right? And we can also say we already have some manual provisioning. We have manually configured some pseudo wire IDs in our environment, and we feel that we might have a conflict or a clash. So, in the resource manager, when we define a pool, we can say the pool is from 1 to 2 million, but exclude some subset of that. So because we've already allocated it, in our network, but we still want automation, so we go and exclude certain sections of the big entire space so that we, when the service provisioning happens through NSO, we don't use the ones that have been excluded, right? So you can do that, and we'll see some examples of that as well. But when we use pools to allocate IDs, and we can do that for VLANs, we can do that for pseudo wire IDs, we can do that for anything, any number that has a local significance, and there is no reason to expose it. I mean, there's nothing. We can still expose it, but we can expose it as operational data of the service. So later on, when the service is provisioned and someone's debugging, something's bad has happened and you want to debug, and you might need to know the pseudo wire ID. So then from a northbound system, you can read all the operational state of your service, and that would give you back the VLAN that was allocated for your service instance for Volvo, the pseudo wire ID that was allocated, and whatever you wanted allocated, right? So you can see all that. So, that's an option as well. So, because it's model driven, because all the APIs are automatically generated from the models, anything that we declare in these models, config state or operational state, automatically is accessible to the northbound system via a range of APIs. So you can use REST API, RESTconf, NetConf, JSON RPC, Java bindings, Python bindings, anything. As soon as you put a new value inside here in the Yang, straight away the API is it's available in the API. The API is updated, right? And we will do this in the lab. We will have a service, and then we will provision that service, and then we will come back and change the service schema. And after we change the service schema, the APIs are automatically generated, and then we can start using the new service schema and start allocating new service instances based on the new schema. Now, in Yang, the RFC, it talks about the right way to change the schema so that it's backward compatible. There's a section, so if you look at RFC 6020, there's a section 10, which talks about how should the model be changed and still be backward compatible. And it's pretty straightforward things. It's just things like if you have an element, don't remove it, because if you remove it, then your northbound system, the interface is going to break. And then things like you can add as many new leaves as you want, because as you add more leaves, it's okay. The instances that have already been provisioned, they're not using it. That's okay, but the new ones can use it. So the API doesn't break. The old API still works, and the new API would also work, because now the new API has got the options to provide those extra fields. So you can still make changes which are not backward compatible. It's just there are some implications, and when you do changes which are not backward compatible, then you will have to provide what we call an update routine with your updated service package, so that it can bridge any gaps, right? So that it can fix up anything that needs to be fixed up. So you need to provide that update. So just be mindful that these schemas can be updated. There's a backward compatible way of changing it, where you just change it in a nice way and you don't have to do any extra work, and it all works. The API is updated, and you don't have to write a single piece of code to update the APIs or anything. Or if you change the model in a non-backward compatible way, then there's a little bit more effort required. You need to write an upgrade routine. I'll pause over there. Any questions? Okay, so now, as I mentioned, when we define a leaf, you have to define the type, what type it is, right? And if you've done any software, you pretty much know all these types, right? Integer, which can be signed or unsigned, and then you have the unsigned one, 8, 16, 32, 64, decimal, string, enumeration, Boolean, bits, binary, leaf ref, identity ref, empty. You can even have a node which can be just empty, and then you can check the presence and absence of that. So something like shutdown, I think they had it as empty, defined that as empty, I think. Maybe they changed it, I'm not sure. And then there's union and instance identifier. So these are the basic types that are available. And even for when you define things, like for example here, we've defined a new type which is based on a int32. It's a derived type. All we're doing is we are putting more restrictions to an existing type. So sometimes you need to have a type with added restrictions. For example, here the range can be between 1 and 4 or between 10 and 20. Instead of you adding that range every time in 50 places in your Yang file, you can define a type def, and then from then on you can, instead of saying your leaf is int32, range 1.4, pipe 10.20, and doing it 50 times, you do this type def, and then next time you define a leaf, you can just say the type of that leaf is my base int32 type, right? So that's what a type def is. But you can see that, with types, you can define for leaves, you can also define the range. So you can say, for numbers, you can say range, what range of values it can take. So this is a Yang-based validation. You can define certain leaves as mandatory or non-mandatory. So if a leaf is mandatory, then when that service is being provisioned, the operator has to supply that leaf. So they can't not supply it. So that's the mandatory field, right? And then if you have range, then the data would have to conform to whatever constraints that you have on the node. And you can have as many constraints on whatever node you want. So it's pretty flexible in that way. And this is the first point of validation in the Yang model itself, right? So you put the validation in the Yang model, so it will check your data, and it will make sure that the data that is being put in conforms with all these constraints. So the whole idea is to try to stop the garbage from entering the system as early as possible, all right? So this is the first line of defense, which is we have these constraints added as part of our leaf definition. And you'll see some more in the examples. Down here, you can see they have defined a type called, based off a string, but they have put a constraint, which is the length of the string cannot be beyond 255. And then you can qualify it more and more and more. So you can build type defs on top of type defs. So what you're saying is not only does the length has to be less than 255, but it also has to be actually 11 or from 42 to 255, and it has to match this particular regular expression pattern. So you can put these validation on your nodes based on your requirements in your Yang file. Yang definition, and the data at the time when the operator is putting in the data, then if it doesn't conform, then that data would be rejected straight away, and NSO would not make any, would not move any further, right? So it's basically trying to validate the data as much as we can. Some more types, okay, and I won't go into these, it depends on what you're trying to do. There's counters and things like that. So as I mentioned in Yang, not only can you define configuration data, but you can also define operational data. And the only thing you do is you define it in the same way. You just say there's another constraint which we say config false, which basically means it's not config. So that's by default, everything is config unless you put config false, and that means it's an operational data. Okay. And then the thing with Yang is that we don't want to reinvent the wheel all the time. If there are certain definitions, certain standards like IP version, IP address, IP prefix, AS number defined by IETF in the INET types, then we just take the Yang file from IETF and we put it in our environment. And then when we design our leaf, we say my leaf is IPv4 address, IPv4-address. And that would make sure that the address of the value that is being put in, matches with an proper IP address. So you can't just give any garbage string. That address would have to match an IPv4. So you can say my leaf is IPv4 address of type IPv4 address. Then the only value that can be entered is going to be IPv4. So this is reusability. You can have some Yang models where you have the types defined in like common files from a public sort of forum like INET, or you can have your own repositories where you see that certain types you have to use again and again instead of every domain and every service guy going and redefining it. You can define it once and get all your software guys to look if there's a common one available, use that first before defining a new one, or have a, whenever you want to define a new type, you might want to basically put it in the common file so everyone knows what's available. Again, standard software practices, right? And all you do is you just import the types. You just go import whatever module, right? So that basically brings in all your INET types. It brings in all these. So this is the INET ones. You might have your own ones where you define your own types and you just import them, and then you can have leaves, and the leaves can use those types that are defined. Here's an example of some more types. There's a percent, so we've defined a new percent type, which again ranges from 1 to 100. This is an enumeration, example of an enumeration. This is an example of a string to represent hour, minute, and you can see how we're using regular expression pattern to make sure that the data that comes in makes sense. It is describing hour, minute. Similarly, you've got a type for route distinguisher, and we have a type for example here, DSCP. So these are some examples, and you can define more. Any questions? Okay, so leaf container list leaf ref, right? So we are all clear on this. These are the ones that we're going to use in our lab, and these are the ones that we're going to see in the use cases. Here is just a quick way, when we communicate with one another and when we talk to one another, we want to have a standard language. So this basically is trying to put the terminology right. We defined Yang, as you saw, using some of the examples that I was showing you, layer 2 VPN, layer 3 VPN examples. So we use the Yang, and it's got a particular way that it looks. So that defines the schema. And then when we want to talk about different elements inside that schema, we use like a directory folder notation. So there's the root, and then we're saying underneath the root there is a container called loopback IPv4. And then inside that container, there is a leaf called loopback, and there is another leaf called IP address. And you can, this is a graphical representation. It's a leaf, and now, so this is the way we show the different constructs. A leaf is shown like this, and the leaf list is shown like with the L in there, a list with a L but the different color, and a container, just color coding, okay? And then, when we represent data based on that schema, this is how the schema is going to the data is going to be encoded in XML. So in XML, so it's actually a list. So loopback IPv4 is actually a list because you can see there's multiple elements. So you can see in XML, we do the first element, which is loopback 1, and the IP address is 10.1.1.1. And then the second element of that list is this here, and then you can see that the loopback for that, the value is 2, and the address is that. So that is the data. The Yang is a schema. The XPath is like a notation to walk through that schema and refer to different portions of that schema. So we use XPath. Again, it's a standard. You can do a search on that, XPath 1.0. I think that's what's supported in NSO at the moment. And this is the different things that would come up. You would have these constructs, leaf, list, container. You'll have the Yang schema, which is built using these constructs. Then we will talk about XPath, where we use a folder-like notation to refer to different portions of that schema. And then we have the notion of data, the actual data. We call that service instance. The service model or the service schema is done in Yang. Then the data, the service instance, usually the payload is represented in XML or JSON, right? So those are the two things when we represent data. Here's some example. So here's a Yang model. It's a leaf called loopback. It's of type integer 32, and it's a range. And if you want to represent an instance of that, then this is how we would do that in loopback, and this is how we will show that in the graphical format. It's hanging off the root, and it's just a leaf. It's got a value of 1, and this is how you would traverse using the folder notation, right? And then these are the constraints I was talking about. A leaf can be mandatory. We can have the type for that leaf, whether it's a int or a string. A leaf can have default value. So if a value is not supplied, we can say, hey, use this default if Northbound system hasn't provided a given value. And then there is some other constructs, must and when. These are really powerful. We'll probably leave this to later, what must and when do. Then we can have like a description for the leaf and some of these other things. I haven't really used them, but looks like there's certain other things that we can put underneath the leaf. And again, this is all coming from the Yang RFC, right? Here's another example. There's a container called loopback IPv4, and underneath that container, we have a leaf called loopback, and we have another leaf called IP address, right? This is how we represent that in the schema format. Container, loopback-IPv4, and as with any software, indentation is the key. Indentation gives readability. Make sure you have some sort of IDE or editor that understands Yang, that can render the Yang and do the syntax highlighting, and you have the right indentation so that someone who's reading it can really read and quickly see the containment hierarchy. So you've got the main container. Inside that, you have a leaf called loopback, and then another leaf called IP address. And when we have data, this is how the data is going to look like. It will be like loopback the leaf is 1, the value for that, and the IP address is 10.1.1.1. Now, because this is a container at the moment, so it can only have one value. It can be either empty container with no value in it, or it can have one value. That's by definition what a container is. And this is the XPath. When you want to refer to, when you're doing leafref, for example, remember leafref, when you want to point to, in your service, you want to say, hey, go and take a loopback from this device /loopback IPv4 /loopback, for example. Then you can pick a loopback from one of the existing one on that device, for example. So that's where you use XPath a lot of the times is for your leafref case. Okay. Now what we've done in this part here is, and I'm going really fast. That's, don't worry, you'll have enough. When you do your lab, you will get to do all of this, right? So you will be looking into containers and lists and these sort of things. Now what we've done is we've changed the loopback-IPv4 into a list. So what that means is we can have many values, many elements in that. And as soon as you make something a list, you have to give it a key to uniquely identify each of the elements. So the key is actually loopback, which is a leaf down here. So the key has to be a leaf. A key can be a composite key, which is like a combination of multiple keys. In this case, it's just one. Sometimes you might need a composite key. All you do is you put in quotation mark all the different leaves that you want to form up the key with, and then you just put them, space between them. So if you wanted the key to be loopback and IP address, you would just go quotation mark loopback space IP dash address quotation mark semicolon. So that's what the composite key would look like. In this case, the key is the loopback leaf, which is down here. So that's actually the interface number for that loopback, which is the key. And then you can see the leaf loopback, and you can see the IP address. You can see the type for the loopback is int32. The type for the IP address is INET. That's the namespace. And IPv4-address is the type def that we were talking about because this is defined in the INET module. So the namespace is basically just a way to uniquely identify definitions. We can have two different service models, and both these service models are, say, attaching to the root, and both of them, they want to call themselves VPN, right? And say one of them is from vendor X and another one is from vendor Y, and they both want to use the name VPN. That's okay. They can use the name VPN as long as they have a different namespace. So that's what the namespace is for. It's sort of like a VRF concept where, we can get just to have a different namespace, we have another VRF table. Similarly, the namespace qualifies a different namespace, I guess. And so you can have overlapping naming and definition as long as the namespace is different, right? And then the other thing here is the unique IP address. Now, as we mentioned, key by definition is unique. So that's the definition of a key. It has to be unique. But in addition to that, if you also want IP address to be unique, then you just put unique IP address. That means every element in that list, in that loopback IPv4 list, every element would have to have a unique IP address. So you can't, two elements, loopback 1 and loopback 2, cannot have the same IP address. So that's really what unique means, right? So you can put all these validations in your Yang. And on the right, you can see the data to represent something that conforms to that schema. So the data, you can see that there are two elements in that list. And this is how we do lists in XML. We just keep repeating the same. And the way we know how this element is different from the next one is by the key. The loopback is different. As you can see, this is 1 and this is 2. And then we have the leaf IP address with the values. And the XPath is basically, again, we use the same sort of folder notation to refer to different things in that schema. And that's how we would represent the list. Okay, so I'll skip, actually let's do one more slide on service design, and then we go to the use case. We might just do one use case today. Yeah, we might just do one use case today. But hopefully all the prerequisites for the use case from a high level, you will be able to understand. Now, when you're designing a service, as I mentioned, the service could really be anything, right? Anything that you have to repeat again and again, that is what we want to automate. We want to automate the repetitive task. And what we find is, 80% of the task, we go for the things that are repetitive. And if you look at all the different things that we do, it might be, 70, 80% are so repetitive that we can automate it. And the 20% might not be because it's very bespoke and it's really customized, and it might not be easy to automate that. So with NSO, if you're starting out, the best thing to do is to start with these repeatable, repetitive ones, which are really repeatable, very straightforward, whether it be infrastructure service, whether it be putting the correct NTP server on all the routers and making sure they're all right. and then coming back and changing the NTP and NSO in one service place, and that goes across your network and fixes all the NTP across all the devices in your domain. For example, I'm just giving an example. It could be that, or it could be updating a syslog server. So you can have a syslog service instead of going device by device and trying to change that syslog service. If that changes, then you can make a service where you can have these common things like NTP server, syslog, all your infrastructure stuff, and then you can push it across all the devices in your network. And then you can do audits, and you can make sure that all your devices are still in sync and no one has gone and changed this. And then if your syslog changes or NTP changes, then you can basically change it in one place, and NSO would push it out to your network to all the devices, right? So these are just an example of an infrastructure service. Then you can have a service like VPN, layer 2 VPN, layer 3 VPN, your classical VPN stuff. You can have firewall service for your firewall rule management, for example. You can have, I mean, there's no limitation. The way I would think about services is anything that you want to automate, something that you need to repeat again and again and again, and it would make sense to automate it. That is perfect for a service. Once you make it into a service in NSO, then you get a whole lot of benefit. You know, one is programmability. You can program that service. You can be absolutely sure that the service has been precisely programmed into your network, and you can do audits in real time and make sure the service is still as designed, and someone hasn't come in and fudged around or tampered with that, any of the devices and the configs. You can even do service migration, so you can have a service and then you want to move it from one PE router to another PE router, and then that might be different platforms with completely different configs, right? So you can have a service for that. So really, there's no limitation as to what a service can be. Now, generally, there's two approaches that you would take when you're designing a service: a top-down approach or a bottom-up approach. When people start out, the bottom-up approach actually is easier or more intuitive, because you've already tried to build a template and have a script to do some sort of automation. Everyone's done that, so you're already aware of these use cases because you're using templates and scripts to do it, and it's just been a nightmare to maintain all these scripts, and especially managing change when the scripts has to change. You know, all the brownfield configuration that you might have. What happens when the script changes? So you might have to write another script to update the previous instances and bring them to the new version and things like that. So NSO handles all that automatically, right? But those are the easier one to pick and go bottom up. So what happens in a bottom up approach is you already know the config in terms of how that service is going to look like in your network. So you already know the config. You already know which devices are touched for a service, for a given service, and what configs need to be pushed to those devices, right? So you have that config. So what you do is you take that config and you generate the device model out of that. So you basically take that config and you tell NSO, hey, give me the data, as per the device model. And so that's the next step that you do. You take the config, you convert them into a Yang-based format, right? And then you think about a good service representation for that, for that service. You think about, okay, what would be a good way to model that service? And what you will base that off is you will look at your configs and you'll go, okay, what parameters do I need to supply from the northbound system? And what parameters can I automatically generate, and what parameters can I automatically infer? So your service model generally would be the parameters that you need to come from the northbound system, right? So that's really how you can go bottom up. So you have the configs, you convert those configs into a Yang representation using NSO, and we'll do that in the lab. Very easy to do. All you need to know is the configs of the router, and then NSO will give you back the model-based representation of that config. And then when you design your service model, you basically think about all the parameters that have to come from the north, right? If something can come from a pool, if something can be inferred from somewhere in the tree, then we don't want to expose that to the northbound system, because the more we expose, the more fields we have in our service, the more inputs the operator has to supply, and everything becomes more, the entire effort is increased when we have more levers and buttons and in our service model. So we want to minimize that. It's a very minimalistic approach, keep it simple sort of approach. And then we just do a mapping. Remember yesterday we spoke about mapping from the service to the device. So that's what we do. So if I bring that back, if I go back to yesterday's presentation and just reiterating whatever I said, so let's go back here. So what I just said was, a bottom-up approach, but a top-down approach is actually the other way around. We start with the service model. We say, this is the outcome that we want, and this is the parameters that we need. And then we basically say, okay, what are the configs that are required on the devices to make that service, to get that outcome from my network? And then we map the service to the device, right? So that's the top-down approach. The bottom approach is basically the backwards. We're saying, this is the config that we need on the device, and then using that, we arrive at a minimum set of parameters, and we model that in our service, and then we draw these lines from left to right, right? So that's the bottom up. Sometimes you'll find it's actually a bit of to and fro. So you go bottom up, then you look at your service, and then you go, okay, maybe I don't need this as a parameter. Maybe I should set a pool for this. So it's a bit of bottom up, top down approach, iterative approach, and then you will end up with something that might be a nice fit, a nice balance between the two, right? So that's generally the approach. So that's what we have to do, which is get the configs, parse that configs using NSO, and make sure and get the Yang representation. From that config, arrive at some sort of service model which basically represents the parameters that we absolutely need from a northbound system, and then we draw these lines from left to right. We say, this node here goes into, the value from this node goes into the node on the right. And I gave you another example for that. So let me see this one here. So this is how it's going to look like. You will do your config, you know your config, and then you will use that config to come up with the, parse that config using NSO to come up with this model, the device model, or the device data as per the model. And then we will come up with a service abstraction where we try to minimize the parameters, and we try to think about what parameters we need to come from the northbound system. And then we basically draw these lines and we say the name goes here in the node, in the description node, and it also goes here because we're using the name as part of the naming of the routing instance or the VRF in the Cisco case. And then the name goes here because we are also defining some policies. And then the name goes here because we're defining a BGP group and we want to use the name. So we might, this is how we take the name field and we apply it in different places. And similarly, the AS number goes there and so on and so forth, right? So this is how it all fits together. Your configs, which get translated as per the device model based on the device's config that is, and then we come up with the service model, and then we do the creation mapping. Once we've done that, that's it. We can create the service, we can delete the service, we can update the service, we can update any parameters just by using the same creation mapping. Okay, so I'm going to pause over there. Any questions? Okay, the first use case I wanted to do was layer 2 VPN. I see that we have 5 minutes to go. Maybe we should start this tomorrow. I mean, we only have 5 minutes because it takes a little bit of time to go over the model and show the APIs and show the provisioning and update and delete and things like that. So let's start this tomorrow. So we've got a few more minutes until the end of the scheduled meeting. Maybe we can have questions. If there are no questions, then maybe we call it a day. Any comments? Krishnaji, anything that you would like to say if you're still around? If this is what, if you're heading in the right track, and if this is what you had in mind?
Hello.
Yes, we can hear you.
Bilal, Krishna is not here right now.
Okay.
So I just wanted to ask some questions regarding your lab.
Sure.
Actually, tomorrow we are going to have a lab, right? So do we need any special softwares or IDE or something? So we can have a proper setup in our laptop or something.
Yeah. So good question. Let me show that to you now. So let me share this. So here, I mean, the easiest way to access the lab is by logging into the port, right? So if you have a VNC viewer, right, so we can log into the port. Otherwise, we'll have to use SSH and all that. But VNC is the easiest way. So this is the lab. So when we start the lab, everyone is going to get this environment. I've got 20 ports. So when you log into the VNC, this is what you see. And there is the binary for NSO. And there is some NEDs in there, like ALU NED. There is an example, VPN example, Layer 2 VPN example, Layer 3 VPN example. There's some sample VLAN example. And there is a slide deck that I will send today, which basically has got all the instructions for the lab. And in this environment, we should have an editor. So we have a Sublime Text editor in this environment, which can be used to update YANG files. So we can open up certain YANG files, and it's already got the syntax highlighter for YANG. So this would probably be the easiest way to do the lab, which is just have a VNC viewer. If you don't have the VNC viewer, then you'll have to use PuTTY and things like that, SSH, and connect to the lab. And in this particular one also has it's a bit slow. It also has, I think I installed a browser. So we don't have a browser, but that's okay. We can access the browser from your laptops or from your. We can have a browser. So when we have NSO and we want to do some API calls, and I'll send this in an email. A browser with Advanced REST client. If you don't want to use Advanced REST client, then the other option is to use curl. So I've added curl into this. So curl is there. We can use curl to do the API calls as part of the lab. So we need to do some API call on the service that we built. And what else? So that's pretty much what we need. We have NSO in here. We have curl. We have editors, as I showed you. We have Sublime Text Editor. Otherwise, if you want to use like a text, like a console editor, we have VI and Pico already in the environment, and that can be used. And Java and everything is installed on this, so you don't need all that. So all that is done. So I've got around, I think I have, let me check, 20 pods, and they have slightly different. So I have around, 20 pods. So we can have 20 participants. I think that should be enough. If you need, we can have 2 people on a pod. If you have more people than 20, and I can share all this information is in the deck, right? So if I open that deck, I'll show you. It's got all the information. Where is it? And let's try to find out. Actually, this is the wrong one. Let me bring up the right one. Yep, this one here. So the information is all in the slide. It tells you if you want to use VNC, you can use depending on the pod assignment. So I will need someone to help me out with the pod assignment so everyone gets a unique pod so that people don't log into each other's pods. So we'll have to do a pod assignments. We've got 20 pods. So if you can help out with that, that would be good. If you can help out with the pod assignment, just give different people different pod numbers from pod 1 to pod 20, and then we can they can log on. Some of these IP addresses might change, so don't worry about the IP address. But don't worry about the Wi-Fi as well. So all the addresses and stuff are here for the lab. So that's really what's needed. Either VNC or you need PuTTY and SSH connection, and you would need access to that IP address that I have put in the chat, 10.6.7.6.3.2.2.2. So you need to make sure that you can ping it. That's a host in Sydney CPOC lab. Actually, no, Sydney SE lab. So just make sure you can ping it. And so that's how the environment is set up. Any questions on that?
वो एक IP दिया है. Sorry, what is that IP? ये हमारे लैपटॉप से तो नहीं होगा. इसका लैपटॉप किधर है? उमंग का.
So I'll put this in an email and I'll send it to Krishnaji, the IP address, the requirement. I guess the only requirement is the VNC viewer on your laptops.
Bilal, this is Krishnaji. Question. So we are at customer side. So do we need to be on the Cisco network?
Yes. So this is in the CPOC lab. So all this is in the CPOC lab. So to access that IP, you need to either VPN into Cisco and then do it like that, something along those lines.
Got it.
And you know how the security guys are, they won't let us put any Cisco property on the public internet. So it's available only on in the Cisco lab environment. Cisco corporate.
Okay, so got it. So what is the alternative? Can we install here? Can you give us a container and we can install as many as we want here? Is there any way to do that?
Yeah, that's an option. I can give you the Docker image and you can just spin it up as many as you want.
Yeah. And you have a virtual device is also part of that image, or we don't need to be? Because if you want to check it out on router, so that virtual router, virtual 18 firewall, all that we need, that is also part of that image, or we don't need that?
So all you need is a Linux virtual machine, right, with a lot of memory, as much as you can have. I think the one that I have has got 256.
That's not the issue, Bilal. So that we will build it. I am saying the Docker image which you are giving it to us, is that image is having NSO only, or if NSO is trying to push the configuration on certain devices, say Cisco router or whatever, do we need to build that CSR 1001 1 kV or something like that, Vector router or whatever, or that image also have something like a NetSIM or that way to push the configuration also? That is my question.
Okay, yes. So no, I mean, look, this was purpose built. This innovation day, we call it Innovation Day. I run it for my customers in APJ, and it's very lightweight. It runs on NetSIMs. All the labs are on NetSIM. There is no real CSR 1kV or XRV. Simply because
Got it. Whatever speed as a device, that device is there. Whatever way, either NetSIM way or this way, that way, that is there. We just need to run this Docker image. That's all. Nothing else is required.
Correct. That's right. Yep.
Give us the image. We will spin up per user, one per user. No problem.
Yep, not a problem. So Krishnaji, I'll upload the image on Box or something, and I'll give you the link. And then you just spin up the if you can get one of your guys, I mean, we just need to forward some ports. We just need to forward some ports for the VNC and for the web and for SSH, pretty basic stuff, and that's it. So yeah,
we'll do that. No issue.
Okay, so let's do that. I'll send you the image, and I'll get you guys to put it on the UCS or whatever compute you have, and I'll send you the PowerPoint deck for the lab that we will go over, and then we can do it that way. Yeah, that's probably easier.
Okay.
And so that's what I have for today. Tomorrow, this is the plan. I still want to go over the use cases. I mean, today was important to put that basic understanding of Yang so that everyone's on the same page. Tomorrow, I would go over the use cases, Layer 2 VPN, Layer 3 VPN, cross-domain, NFV, NFVO, all the use cases. And also, I will send you the Docker image and the lab. So after tomorrow, end of tomorrow, then you can use the Docker image and you can use the lab material. It's all in a PowerPoint. It's very self-explanatory. And I will ask you all to start working on it. So you have Friday, Saturday, Sunday, Monday to work on that material. It's pretty straightforward. And then when we meet up next week, then we can get into more detailed questions that you might have, and we might do whatever follow-up post that. So that's the plan.
So that is good. We'll do that actually. If get the Docker image, we'll bring up. Tomorrow we can try with one image and how it looks like, and if there is some changes need to do, we can do that. And then we'll just spin up per developer one image, so that's not problem. So, question: do you want to do small exercise today to write down Yang model? Have you reached till that stage? Small, whatever, kind of a hello world kind of thing.
Yeah, I think we haven't got to that stage yet. People can give it a try, but I think they will need that lab environment before they can play around, right? I mean, yeah. I mean, they can model something and give it a try, model something, get the Yang RFC, have a read through it. But once you get the lab environment, then you can actually write stuff and compile the Yang and look into it and call the API, the auto-generated API from the Yang. Then they can do all that. So that would probably start once we have installed the image. Once we have the Docker containers up.
You want to guide us on basically which IDE you use for Yang, which gives actually correct syntax, colorful thing, autocomplete. Is there anything available as open source, or which one you use? Do you want to suggest the best practices to that?
Yeah, so a lot of that is in the Docker container, the editor, when we come to Java and Python, it really depends on the person's preference. I use Eclipse for all my Java, and I use PyCharm for all my Python. And I'm sure everyone's got their own preferred IDEs. I can do a session on Eclipse, how to set up Eclipse with NSO, and do, for example, stepping and tracing and breakpoints and things like that. Let's do that after the lab. Those are more advanced sessions. We can do things like having Eclipse with NSO, doing the service model development on the fly in Eclipse and debugging on the fly, for example, and all those sessions. We can probably do it after we've done the basic lab, because then the people will get some appreciation of NSO, and then the next step. The lab that we have is really basic. It doesn't even use Java and Python. It only uses XML-based mapping. Once that's done, then the next step after the lab is to start looking into more advanced topics like Java and Python, and using Java and Python to help out with the creation mapping. So that's the plan, one step at a time, and I think that's probably the best way to go about this.
No problem. Good. Thanks, Bilal. Anybody has any question? Hello, Bilal. Hello, Bilal.
Yes, please go ahead.
Can you use NSO API?
So
API document.
Oh yes, I saw the mail. Yes, I'll send it to Krishnaji. Krishnaji was asking for it, and I'll send you the API. But in a nutshell, NSO API depends on the model that you drop on it. So if you drop a layer 2 VPN, straight away you get the layer 2 VPN API from the Yang model. If you drop a layer 3 VPN, then you get the layer 3 VPN API from the Yang model. So NSO, what it does is it automatically generates the API from the Yang. So the API is as the designer designs the service. So if you're the designer, you are basically crafting the API automatically by the mere fact of your Yang definition, right? I'll send you the documentation which talks about how can we look at the Yang and automatically know what the API is. So the document talks about if this is the Yang, then this is how you add an element to the list. You do a post. This is how you delete a resource. You do a delete and you put the URL, the path, the XPath to that resource. How do you do patch and put for if you're doing REST? If you're doing netconf, then it shows you how to do get config, edit config, using a netconf API. If you're doing RESTconf, then it tells you how to do all that, right? So I'll send you the documentation. It's not the documentation. It actually is a guide as to how to know what your API is going to look like based on the Yang model that you have just defined, right? So that's how it works.
Okay.
So for example, you have a service layer 2 VPN, and then you go change the service and you add something to your service, for example, like you add a new variable or a new leaf, then the API automatically is updated with the new leaf that you have just added. So it's automatic. The API is dynamic. And if you're a northbound system, you can actually, do a get schema. So if you're a northbound system and you're using JSON RPC or netconf, you can go to NSO and say, hey, give me the schema for layer 2 VPN. And that would give you the schema, and then you can automatically start calling APIs. So it's like a really high-level it allows really high-level machine-to-machine interaction where a northbound system can dynamically learn the API of NSO services and then start consuming those services. So it can get really powerful in that sense. So it's pretty all those APIs are automatically generated. So, there is no need to pass documentation and give documentation to the system, and there is no need to go and write a handler for for your post or get and things like that. It's automatically done for you, right? So that's one of the big benefit of NSO. It saves you a lot of time. You can go 90% faster because of all the APIs are auto-generated. You only need the one creation mapping, the transactional guarantee. So that's all the benefits, right? So and you'll see this in the lab. You'll see this in the lab.
Okay. Thanks.
Okay, so let's reconvene tomorrow same time. Hope today was useful, and we'll talk again tomorrow. Thank you very much.
Thank you.
Thanks. Yeah.